Welcome everybody to a panel on notes from the field of implementing ASHRAE Guideline 36. My name is Armando Casillas. I'm an energy technology researcher at LBNL, and I will be moderating the session. I have a lot of affinity for folks that are on this call today. I have originally background in facilities management, so I really got my start there. Worked with a lot of building operators, campus energy managers, HVAC technicians, really having my boots on the ground there, and it's always really sobering to hear points of view from folks like you today, and especially being in the echo chamber that is a national lab. So I'll get started here. For those of you who are not quite familiar with ASHRAE Guideline 36, it is considered the best-in-class control sequence specification for high-performance HVAC systems. It provides an accessible toolbox of standardized control approaches that have the power to reduce building energy consumption compared to traditional customized design control solutions of the past. Although simulation studies, and there's been a lot, especially from LBNL, and field research, have projected energy savings and enhanced HVAC performance, the widespread adoption of Guideline 36 in commercial buildings has not quite yet occurred. In this panel discussion, we'll have 3 building operator staff, operations staff members, 2 members from Sustainable Berkeley Lab, Chris Wyan and Raf Vidi, and Joe Don Breda from Ohio State University, who will share their firsthand experiences with the challenges and opportunities associated with implementing Guideline 36 in existing buildings. However, 3 of you doing today, are you okay and able to speak? All right. Well, again, for joining, we're going to give each of you an opportunity to introduce yourselves and give the audience a short intro to your experiences with Guideline 36 and building operations as a whole. So I think, Chris, you're first. Please go ahead.
Hi there. My name is Chris Wyant. I'm a control systems engineer with Berkeley Lab. I have about 20 years of experience in the BAS industry, and have been using Guideline 36 sequences for about the past 10. When I first started working at LBNL 10 years ago, we had already built 2 new buildings with what has become the sequences that are now in Guideline 36. This was prior to the release of the guideline. And we did have a lot of struggles initially with those implementations, and over the years we've gotten our staff better trained, and including myself, and are now successfully using Guideline 36 sequences for pretty much every project on our campus.
All right, next we have Raf. Welcome, Raf.
Thank you. Yes, I work with Chris. We're on the same team. I started as an engineering consultant, specialized in energy efficiency, for a few years. So I was on the side of recommending Guideline 36 as something that people should implement, but without necessarily diving into how to do it in very much detail. And then I joined LBNL, and we conducted a couple of efforts to recommission existing Guideline 36 controls. We've done that in 2 labs with good success, all implemented in ALC, and achieved good energy savings of 14% and 22% overall energy savings for these 2 whole buildings. We also implemented new controls, and that was a special case where our largest lab building had some reset controls for air handler set points, but they weren't demand-based. They weren't trim and respond, as is the case in Guideline 36. And that building doesn't use ALC, and we decided to actually try and implement the Guideline 36 trim and respond algorithm in SkySpark for the air handler set points. And we did a lot of work to support that, recommissioning the zones, fixing a lot of leaky reheat valves, broken dampers, and whatnot. we had really good success in that building, achieved 26% overall energy savings, including 57% natural gas consumption reduction. So that's my main experience with Guideline 36. I added this little blurb about the spirit of Guideline 36. That's because Chris and I, in preparing for this, realized that we hadn't actually looked at the document in a very long time. And so for me, Guideline 36 meant trim and respond for air handling unit, duct stake pressure set points, and supplier temperature set points. But there's, of course, a lot more to it. But nonetheless, I think what we were striving for was really matching the services that we're providing to the actual need. And I think that is the spirit of Guideline 36. And so that includes demand-based resets, and that also includes implementing schedules and setbacks down to a fairly granular level. With that said, the last point I want to make is about the challenges and the risks. There is added complexity, and so it takes some effort to implement those sequences successfully. And it's really good to keep in mind that poor outcomes are possible, in particular with demand-based resets. If you don't spend the required time to make sure your demand signals are legitimate, you can end up with, running 55-degree supplier temp reset all the time, or supplier temp set point all the time. That's a fairly classic issue. So it's worth keeping that in mind. But what we found is if you have the bandwidth to make it work well, you can achieve really good results.
Thanks, Raf. Yeah, great insight and summary there. Next, we'll have Joe Don introduce himself.
Hello, everybody. This is good afternoon for me over in Ohio. I'm a senior mechanical engineer with Ohio State University, Wexner Medical Center. I'm about a 20-year guy. I've spent the last 5 years in a user/owner role. And I've really gotten deep into Guideline 36, I'd say in about the last 3 years. So we have some big energy reduction goals at the university. We also have an issue in that we have we have a lot of real estate and a lot of HVAC systems. Most of our HVAC systems are multi-zone VAV air handling systems, and many of them have totally different sequences when you go from one air handler to the next, from one building to the next, from one part of campus to the next. So we've had goals to reduce energy and to also try to standardize on the sequences of operation that we use at our equipment, which has kind of led to our interest in Guideline 36. So going back about 3 years, started off as an interest where we started kind of tiptoeing our way into using portions of Guideline 36 strategies. We saw some pretty quick success as measured through some virtual energy meters that we installed within our DDC controllers. So once we saw some of the savings, we wanted to go bigger with it. We picked out a building that's part of our hospital complex, but it's a lower risk building in that it's mostly office with just a little bit of patient care. We rolled out even more parts of Guideline 36 sequences in that building. At the end of 1 year of compiling some of our energy bills, we found that we had a 27% reduction in total energy use. And this was simply from updating the programs in our DDC controllers in the building. In a few cases, we did have to replace some controllers just because they had insufficient memory, but for the most part, it was a low-cost project. We had fully programmable controls in the building already that we were able to utilize. And yeah, that was a big win for us that has now led into us standardizing on Guideline 36 sequences and rolling them out farther across the hospital. So I'm a user of Guideline 36. I've also I've edited the sequences for our use at the hospital. I've had a hand, I'm not the main programmer, but I've had a hand in writing some of the programs for the DDC controls. And I'm also a member of the Guideline 36 committee. I joined shortly after becoming a user at Ohio State. So that's a little bit about me.
All right, thanks. Well, once again, I think it's been really nice to be able to talk with you. You three individually prior to this session, really understanding where you come from with this. And yeah, I think I'm just gonna get straight into it. I welcome the audience to also ask questions if you feel so inclined up to this point. And if any of my questions or discussion topics inspire you to ask questions, please feel free to do. I can see those questions and link them into the conversation here. So my first question for you three is, what drives you individually in your organization to adopt Guideline 36? And do you feel like you've had the institutional buy-in overall?
I'm happy to kick that off. I think I nailed a portion of it during the intro, right? So we wanted to be able to standardize on things because we have so much equipment across our campus, and we have big energy reduction goals. And I'll start off by I want to get the message out there that one thing that I learned when we started implementing this is that the opportunities in a VAV air handling system, if you have legacy sequences of operation, and I'm saying that meaning like, the sequences of 10 to 20 years ago, Guideline 36 has come a long way since those. And I think that a lot of that existing equipment has so much capability to operate far more efficiently. And if you have fully programmable controls with the capability in place already, there's not a whole lot of spending that needs to happen. If that's not the case, then you are looking into doing a controls hardware retrofit to implement some of the Guideline 36 sequences. But that's really what drove us. There was a second part of your question, Armando. I lost it.
Yeah, it was more so if you've I feel like you've had an institutional buy-in with this effort.
So what was so helpful for us was the way we moved into it. So we didn't start off with an entire building. We said, hey, let's pick an air handling system that's relatively small. So for us, we had a 10,000 CFM air handler. We said, all right, there aren't too many spaces associated with this. I think 15 to 20 zones or VAV boxes. So it was easy to get buy-in from our technicians and our controls people because we knew that it wasn't something monstrous that we were going to have to babysit really closely. And we also know that the building that we put it into was not a very high-risk building. So by starting out that way and then getting the feedback on how the system was working, going around and talking to users to see if they, you're kind of pulling people to see if you're getting any complaints or if anybody's noticing any changes when you implement it, and asking those questions carefully. But that's how we were able to successfully get buy-in.
Thanks, Shogun. Chris Raff, any thoughts there before we move on to the next question?
Yeah, I do have some thoughts on that. So like I said, when I started at LBNL, we had the same issues that Jodan is describing with unique sequences in every system. We have 100 buildings and no two sequences of operations are alike on paper. And I think that is a huge challenge for technicians who are trying to modify or even just maintain these systems. And so the key priority was standardization. How do we get the same results from one project to the next? And our initial specifications did not define sequences of operation. This gave us the opportunity to have one standard that we can point to, that we can say to our design engineers that we're hiring to design our projects, follow this standard, this guideline. We don't want your cut and paste sequences that you use on every project because we have a different engineer on every project. And so we end up with all these different firm standard sequences. Guideline 36 gave us the opportunity to say, this is what we want to follow. These are tried best practices that have been vetted by many different professionals, and that alone makes it a lot easier. It was difficult though to get buy-in on that, specifically from our engineering staff, because it's a 287-page document, and people don't really want to read a 287-page document. I think a lot of people struggled with the concept that it's a document that's meant to have a lot of things deleted, and you really are just pulling out the important sections that apply to your project. But that was actually a challenge that probably took several years to overcome, just with acceptance to finally get that to be our base specification.
Great. Thanks, Chris. It's really insightful. I think that kind of goes into my next question here is, you know, I've seen a few reports about the average age of you know, our building operations staff nowadays. A lot of folks that are on the older side, set in their ways. And I'm wondering how you three have ensured that your HVAC technicians and building operations staff have the information necessary to really believe in the value of Guideline 36 and not get overwhelmed or, you know, with this new age of control sequences that we're seeing.
Well, I guess I'll say for our in-house staff, and we do most of our controls work in-house. There was a challenge because people didn't understand the sequences, not because they didn't accept that they were worthwhile to follow these sequences, but because simply the concept of a trim and respond reset compared to the standard resets that we had in all of our buildings prior to implementing these, which was outside air reset, or just looking at the, you know, most open valve or damper position to adjust your set points. On paper, it's hard to understand. It's actually something that I almost feel would be best communicated through a cartoon, so that the basic concepts of how a trim and respond loop actually works doesn't look like several pages of math. But once people started to understand it, once we had enough buildings where it was implemented, that it became something that needed to be understood, instead of just being a one-off building that, you know, everybody thought was working fine because it had been recently commissioned by a professional. Once they started to understand it, I think we've had no trouble gaining that acceptance.
Yeah, definitely. I think that's a great point, Chris, in terms of being able to communicate these concepts. You know, the guideline is pages and pages of text, right? To be able to modularize these concepts in a way where existing workforce can understand the concepts, but also the new workforce, right? Folks that are just getting trained. I think it's important to continue to think about how we can better communicate these sequences. Yeah.
So I heard the word excuse me, heard the word communicate there a few times, and I think that's pretty key. I think what could make things go sideways in a hurry is if you have a project come in and you put in Guideline 36 sequences, you dump it on some technicians who've had no exposure, and you walk away. Right? There needs to be, I think that was a lesson that we learned, was it's not just, you don't just implement these for the first time and walk away. There needs to be some level of support, at least in the beginning, when you have people that are just becoming exposed to it. So whether that's in-house staff, if that's a capability that you have, we have that luxury. But if it's not, then whether it's through a commissioning team or a good controls partner or a good engineering partner, someone's going to need to spend some time, I think, hanging around for a while to make sure that the trim and respond is working the way it's supposed to. And really, I mean, for us, what we've done is we say to the technicians, hey, we're making these changes. What should happen at the air handler level is it should see if one of my zones has a problem, it's going to react to that zone. And if you see that it's not reacting to demand somewhere, get on the phone with us. Like, we're here, we're available, we're supporting you. Let's talk through it and let's figure out what's going on.
Yeah, that's great.
You know, the one more thing I want to add to that, I'll try not to run on for too long, but it's really been helpful for us too to share some data back with the users.
Mhm.
So if you can develop some trends, whether it's the utility bills or if you can set up trending that shows energy use, and then, you know, pull them into a meeting to say, look how we did. Like that now we can celebrate the victory as a team. And it's not just, you know, you're not just leaving someone out there who wonders, oh, I was told they were more efficient, but I don't know. So I think it's important to share the wins.
Yeah. Definitely, Jonah. I think that kind of ties into the question that someone asked. Dominic DePinto is asking how much follow-up tuning, once you get it installed, is needed to make sure you are getting to the performance goals, right? So I think that's something that, as you mentioned, you actually program the sequence, make it live. How do you integrate your staff to to tune and make sure that you're getting the performance goals you expect?
So we use so Guideline 36 has some really, really cool rogue zone features, and it also has within it, there's verbiage of how to build automatic fault detection and diagnostics at the controller level if you choose to do it that way. There's also third-party options that are out there. But for us, it is a continual process. So I get, so out of our BAS system, I get an automatically generated report that gives me fault conditions and gives me rogue zones once a month. And I'll be candid. We're figuring out the process right now because it is something new. But we do have a couple people, we put our heads together. We try to get together once a month and say, hey, look, there's a new rogue zone. I may have lost. Can you still hear me, Armando?
Yes.
Yep.
Yeah.
Yes.
Okay, good. For some reason, my screen went blank, but if you can still hear me, I'll keep talking. So we get that rogue zone report. We might see that a new rogue zone has showed up that's inhibiting our reset strategies at the air handler, and then we'll have to go out and address it.
Yeah. Yeah, that's great. I
And
think that
similar for us, we
Okay.
have tools both in the building management system as well as in our data analytics platform that help us really see the whole system at once, see where the demand's coming from, and it helps us diagnose issues relatively quickly. So it's also an ongoing process. And I would just like to say that is maybe, I mean, it's not just an additional burden. It actually helps you find real issues with zones that you might catch before the occupant notices. So that's really nice.
Yeah, I think well, one of the questions I had here, and Raf, I think you said the word demons, which I think is a nice way of characterizing faults. I was going to say, how did the presence of faults in a building affect your approach to the implementation? I know that the guideline kind of assumes a perfectly working building, which is very often not the case. And I'm wondering how you folks tend to approach a building, with existing faults as you're implementing it.
You know, for us, one thing that we did, at least after our first run, one of our lessons learned was an existing system is very likely to have some faults, and it's very likely to have some rogue zones that are going to need to be dealt with. So as we roll this out across our campus, what we're doing is we're putting in fault detection and rogue zone detection at the zone level before we even update the reset strategies at the air handler, so that we can start monitoring, figuring out where the faults are, figuring out where the rogue zones are, coming up with a strategy to address them, and then continuing on with sequence implementation from there. And it is, I think I mentioned in the beginning, it's not just dump in the sequence and walk away. So someone has to take a look at that. So if it's in-house staff, that is awesome. But if it's not, you got to make sure that the partners you're working with, if they don't have the experience with Guideline 36, then they need to know their help is going to be needed from an owner to find the faults, find the rogue zones, and help make recommendations to deal with those.
Yeah, and I'd say similarly for us in our ongoing commissioning process, when we start to work on a new building, we recognize that we need to first address all of the zone level issues, or as many of them as possible, before we can start really tweaking and optimizing the sequences at the system level, at the air handlers. Because in a 10-year-old building, I mean, it's amazing how many zones in a 10-year-old building are already not working properly. And it takes a lot of effort just to get through those issues, which is mostly failed actuators for the most part, or just set points that people have tweaked as the result of hot and cold calls. And in our first buildings, the first buildings where we implemented these sequences, it was exactly what Raf was saying in the beginning, where every set point was running at its least optimal spot as a constant, because the rogue zones were dominating all of the resets. And also, nobody understood that. We didn't have the diagnostics built in, as Jodan's discussing here. We didn't have any of that to show us where the requests were coming from that were driving the set points. And we didn't have any trending available or set up to show us that in a simple manner. And RAF has created a lot of views in SkySpark to help us identify those problems. And so we review them once a month to make sure that we're staying on top of all of those issues.
Yeah, that's great. Thanks, guys. Once again, great insight for folks listening out there. Marco has been asking a couple questions. Marco, I'll address a couple of them here. Marco's asking Jodan in particular, what are you using for fault detection? Alarms on the BAS or dedicated FTD tools? Can you go a little more into what you mentioned in terms of device level AFTD?
Yeah, we're having some success right now with what I'll call controller embedded fault detection. So writing a fault detection program that lives in the controller. So we're doing that both at the VAV and the air handling unit level. And then having a report that's output from there to give us insight into faults. Now, that said, we're also testing some third-party stuff. I think that there's a lot of third-party offerings out there that have a nicer interface than what we get staring at the BAS screen with the fault detection that we've created. And we're dabbling with some of that stuff to see if we can get the same kind of value that we've gotten out of our controller embedded fault detection. So we've written our own programs, and we're comparing that to some of the offerings that are out there in the field. And what was the second part of that, Armando?
If you are just using alarms on the BAS or dedicated FTD tools, but I think you answered that question, Jodan, pretty well. Yeah, thanks. Okay, I think you know, one of the things that we did want to talk about with you guys is, despite your successes, I'm wondering if you guys could maybe talk about some frustrations you've had with the guideline or implementing it. If you could describe one of your biggest frustrations you've experienced so far with Guideline 36 implementation. You're really trying to paint a picture of what could potentially go wrong or be frustrating when you're implementing it.
Yeah, I could talk about that. Again, back to our initial implementations, we had 2 buildings where these sequences were implemented, and they were different control vendors. The sequences as implemented are so different that I didn't realize that they were trying to do the same thing. And so the lesson for me on that is, one of our controls vendors sort of has adopted these strategies and built them in as standard parts of their control logic. That makes it very easy for us to have consistent implementations regardless of the actual controls installer, whichever company gets hired for that particular project. We still get similar results, whereas with our other vendor, it's a different results every time. And not having that sort of buy-in from the controls vendor, I think, is a huge challenge in trying to get consistent results.
Thanks, Chris.
So I've got a few. So I'll try to be quick. We had some instances where energy went up initially, and that was largely driven to rogue zones. We hadn't addressed rogue zones before doing a full implementation. So we had a couple air handlers where zones had been starved for a long time, but there weren't complaints, or the complaints just weren't loud enough. And we put in these demand-based strategies, and suddenly we had fans running at 100% because there were a couple of VAVs out there that just either had poor ductwork conditions or foul reheat coils, and they weren't getting the air that they needed. So that was one thing. I've ran into existing controllers that we were optimistic that we were going to be able to implement the sequences and found that we couldn't. So we had to replace controls. So that's something that comes up. And then the last thing I'll say is we're in an A climate zone over in Ohio. So humidity is a consideration that Guideline 36 doesn't address very well. Now, I know that there are some people putting some thought into that. But for us, we had to get creative and come up with our own strategies to make sure that humidity didn't get too high in a building when supply air temperature reset starts to kick in during the humid season.
It's great insight. Thanks, Jordan. All right. Well, I think there was another question here. I think Larry just recently asked, have you encountered faulty sensors as a frequent obstacle to successful Guideline 36 implementation? How has that played a part?
You know, for me, that's not, I wouldn't call faulty sensors. It's happened. It's not as common. What's been more common are reheat actuators that are failed in place, or yeah, it's just some way somehow not working. So zones that are just getting reheat that shouldn't, or valves that are passing flow through that shouldn't. What I have seen, I guess this would be considered a faulty sensor in a sense. We've had sensors, as an example, duct static pressure sensor. It's 15 years old, and we have a service contract. Someone comes out and does maintenance on it. However, what's happened is, after a couple years, it's 0.1 inches off. Someone puts in a 0.1 inch calibration. Then, maybe so many years later, suddenly you have a half-inch calibration in a device. Don't allow your static pressure reset to go down below whatever the calibration number is on that device, or you can have some issues where your air handler starts tripping on and off. So I've ran into that. So that's something to check. If you're implementing this in an existing building, see what type of calibration numbers have been put in on your devices, and if something is more than just a little bit, have the device replaced.
That's great. Let me see here. I'm trying to field some questions here from the audience. An anonymous person asked, how did you select the specific parts of Guideline 36 to implement?
Well, I'd say, as I was mentioning before, it's a 287-page document that has lots and lots of text for many different equipment configurations. If you go through that document and start deleting entire sections that don't apply, you don't need the chilled water plant or hot water plant section, or you don't need the fan coil section, it gets a lot smaller pretty quickly. And also, a lot of that document is annotations for the designer that also wouldn't make it into the final sequence of operation. So it's really, if you go through that document, and you can download it as a Microsoft Word document, not just as a PDF once you purchased it. If you go through that, then you can literally just start deleting all the sections that don't apply to whatever you're implementing, and the final result is generally a pretty concise sequence of operations for a single piece of equipment or a single system.
You're forcing me to work my memory here, but one thing I recall is that we had reset strategies based on older sequences or someone's company standard sequence that just weren't working well, and we had a really hard time diagnosing where the problems / rogue zones were. So in the beginning for us, we said, hey, let's try what's in Guideline 36 for supply air temperature reset and static reset. We saw that as some of the potential low-hanging fruit in terms of big energy savings potential. And we knew that those particular features were not working well in our older systems. So that was the beginning. From there, once we had success and we said we want to do more of this, we created a sequence for an air handling system that we could review with our engineering department and say, what don't we want to do out of this? Let's narrow this down to what we feel comfortable with, apply that, and then maybe open up the book a little bit more.
Yeah, that's great.
You know, if I could quickly, there's because I've heard about editing the document a few times during this. Control flow. I don't know if Armando, is that something you're familiar with?
Yes, definitely. Yeah, control flow is something that we're really proud of, and we're we're slowly getting the word out. But please, Jordan, it lends more credibility coming from you than me plugging an LB.
I've got to dabble with it since it's been out. I realize it's kind of still in its infancy in terms of it doesn't, it's not everything in Guideline 36. I think it's just a couple of the air handling system options right now. But in my experience using control flow, what would have taken me at least 4 hours of work takes me about 10 minutes. So yeah, it's a Guideline 36. I think of it as a spec editing tool. It's web-based, it's free. You go in there and you click some options in terms of what type of system you have. Do you have a fan array? Do you have a single fan? Do you want to do building pressure control? Do you have a return fan, a relief damper? And then it generates what I would call like a good 80% first pass sequence.
Yeah. That's great.
And I don't know if it's worthwhile. If someone on the team could help throw that into the chat, that might be a nice thing to send some of the.
I think Marco, thanks for putting it in the Q&A. At least there's a control flow page. Yeah, you guys have been throwing out a wealth of knowledge. I hope someone's taking notes here. It's good stuff. I'm glad this is recorded. Let me see here. We do have a few minutes left. I want to get to some of these other questions here. Let me see here. Dominic asks, and this is a spicy one maybe. All of you are from large, sophisticated institutions. What advice do you have for the owner with a one-off building?
I'd say, from my experience as a installer prior to working at LBNL, when I was receiving specifications from many different engineering firms for the projects that I was implementing, one of the challenges again was that every sequence of operations was unique. And so even if it was a small building or a single building owner, we were basically starting from scratch on the logic and the software for every project. And I'd say that if we get to a point in this industry where standards like Guideline 36 are becoming the norm, then the controls vendors will be able to implement projects more efficiently, but that will also mean that the commissioning processes will be simpler and smoother because we already have standards that are being followed in the software, not just in the text and the sequences that are being written, but actually in the software that's being implemented by the vendors.
What I'll say is, if this is something that you're looking to implement in a building, and I would recommend at least exploring it, I would partner with someone who is experienced and can back that experience with Guideline 36 implementation. So I would ask someone, to provide at least one or two other clients that they've worked with that you could reach out to and contact and just confirm that, that experience is there, because while it's been around for years, it hasn't been around for that many years yet.
All right. Yeah, but we're running out of time really quickly. Let me see here. I want to ask a question here related to education materials, right? I think we talked about workforce development. Marco's asking, what are the best resources to teach, our students? And in there, I'll also throw in maybe trainees, building operations trainees. Is there any publicly available material that you all can refer folks to?
Is it okay for me, because I don't know what the commercialization policy is here. So there's a user guide out there. It's called the Advanced Building Automation Systems Best Practice Guide. Are you all familiar? I know that the link to it that I have is on a particular consulting engineer's webpage. Is it okay for me to paste that?
I mean, I'd say for folks that are interested, yep, please go ahead, Jodan. I mean, I don't think we're necessarily breaking any rules there. I think folks are just really interested in getting more materials out there. So, yeah.
Right, and I'd say that that same consulting engineer has YouTube videos of many presentations on the subject as well, and a number of white papers on their website as they were involved in the development of the guideline. I would think that those videos might be one of the most digestible resources for training purposes.
That's great. Yeah, I think what I'm hearing is there's a thirst for resources and links, and I think that we need to work to compile these for folks to access these things a little more readily, right? I had a question with that here is, do you guys have any tools or workflows that help you determine whether or not a building is a good candidate or a bad candidate for implementation of Guideline 36? Jodan, you talked about this a little bit in our prior conversation with me. I'm wondering if you can start off there.
Yeah, I would say, if it's a brand new building, then it opens the doors to anything and everything. So new buildings are good candidates, as long as you've got the good team to work on it, the experienced team. If you're looking at an existing building, if you are in a position to do a full-blown controls, retrofit because the controls are more than 20 years old, that could be a good candidate. Existing buildings less than 20 years old, if you have fully programmable DDC controllers, you'd want to work with a controls expert to make sure that the controllers had both the memory and that you've got the network speed, scan rates at the device level, those types of things, just to make sure that you can handle it. But if you're dabbling into this for the first time, I'd say try to pick something that's lower risk, right? So I work at a hospital. I'm not going to start applying this in an air handler that's serving operating rooms as my first go. I'm going to pick, hey, where do we have an office wing where the worst thing I'm going to do is make someone in a corner office get a little upset with me.
Point.
Yeah, for existing buildings, I think it'll depend for sure on the type of control system you have. We have found, we use two main control systems, and I think to implement most of the Guideline 36 sequences is much easier in one than in the other. So I think that's a limiting factor. And then it'll probably be a partial implementation anyway. I think for to implement, for example, the zone-based ventilation controls in an existing building is going to be much harder than in a new building.
And one big challenge there is if you have, at the field level, if you have application-specific controllers where you're not freely programming the logic in those controllers, you can't simply add this new fancy request-based request generation logic. And so then it has to be done from a top-down, from the supervisory level, where you're putting a lot more processes on the supervisory controllers, and they have to be sufficient to be able to handle that extra load. And it's also generally messier to do it that way.
Definitely. Yeah. So I see here we're out of time, but I had one last question for you guys and see if you guys can maybe if you guys are up to the task here. What would be your 30 seconds, sort of elevator pitch for implementing Guideline 36 that you'd give to a building operator that is on the fence about implementing it at their facilities?
The energy savings have been worthwhile for us, and I really like the way that a lot of the logic is pushed down to the controller level. So the rogue zone detection and the fault detection stuff, I think is amazing for staying ahead of problems in your building.
Yeah, energy savings and comfort improvement, because it encourages you to resolve issues, for the whole system down to the zone level, from the zone level to the whole system. And I think the outcomes in terms of comfort can be really good.
And I would tell it standardization. Just the fact that these are published by ASHRAE. These are sequences that are available to any engineer who's designing a new project. To me, it's a huge advantage to have a standard approach to every project instead of trying to reinvent the wheel every time.
There's a lot of people out there trying to sell a proprietary black box that'll save you energy, and this is not that. So yeah.
That's great. I am seeing in the chat that some of the resources that were mentioned today were posted in the Q&A and not in the chat. So we should figure out, maybe I'll work with Kim and other folks to figure out how we can compile some of these things we talked about today. Folks can look at the recording hopefully after the fact. But yeah, I just wanted to say once again, guys, thanks so much for joining us today. This was a great conversation. I learned a lot, and I hope folks on online also did as well. Yeah, sorry we didn't get to all the questions, but hopefully you guys learned a lot today. Thanks again, and yeah, we'll sign off now.
Thank you.
Thank you.
See you guys. Thanks again.